In today's video, we are going to be looking at how to combine like terms with equations. So in today's lesson, we're going to be combining like terms. This is one of the first steps whenever we are solving any type of equation. We are looking for things that we can combine so that we can make our problem a little bit simpler to solve. So let's just start by identifying what a coefficient is. So the coefficient in this equation of 3x plus 21 is that 3 on the x. So whatever that number is in front of our variable, we would call that a coefficient. The 2 in this problem, that plus 2, is a constant. We can combine our coefficients and our constants in an equation to make things simplified so that we can begin to solve our equation.
In our first example, we are going to look at 3x plus 2 is equal to 21. So when we look at this first example, what we're trying to do is we're trying to combine like terms, right? Remember, that's what we're doing in this lesson. We are going to combine like terms. Something that you might want to do is you may want to go through your problem and you may want to do like maybe a single underline and a double underline underneath things that are the same or similar. So I'm going to do a single underline underneath numbers that have a coefficient, and then I'm going to do a double underline underneath all of my constants. So in this problem, we have one number that is a coefficient attached to a variable, and we have two numbers that are constants. We can combine these constants. We don't have anything that we can do with our 3x. Remember, we're not trying to solve this equation. All we are trying to do is simplify. If you see the word simplify, it probably means that we're not trying to find out what x equals. We are just trying to make things a little bit easier to work with, and that's what we're doing here. If we remember from a past lesson, what we can do with this equation is we can do the opposite operations. Since we are adding 2 to 3x, we are going to subtract 2. And when we subtract 2 from the left side of our equation, we have to do the same thing to the right side of our equation to keep things in balance. So here, we would do 3x plus 2 minus 2 equals 21 minus 2. We would go ahead and work this out. 2 minus 2 is 0, so we would have 3x is equal to 21 minus 2 would be 19. And we would be done right here. This is our simplified equation. We cannot do anything else to make this easier to solve. So in our second example, we are looking at x plus 3x plus 4x is equal to 22. Whereas last time we had more than one constant, here we have more than one value that has a variable in it. And we are going to combine these like terms, remember that's the name of the lesson, in order to simplify this. We're not trying to find an answer. So if we were to simplify this, we would need to combine like terms. We're going to go ahead and do the same thing we did last time and underline. So let's underline any time that there is a variable. We have x, we have 3x, and we have 4x. Now, I underline x here, and we have to understand that the coefficient on this single variable here would just be a 1. The reason that we don't have to write that in mathematical terms is this is just 1 times whatever x is, and 1 times any value is just itself. So that's why we can just simply write x, a little extra tidbit of information. So if we were to go ahead and combine these like terms, we have 1x plus 3x, so that would mean we have 4x, and if we add 4x to 4x when we combine 1 and 3, we would have 8x is equal to 22. And we don't have anything to combine with 22. It's the only constant in our problem, and it's the only thing that's double underlined here. So we would be done simplifying this equation. So this third and final example is a little bit longer than the past couple that we've been doing. We're going to follow the same steps though in order to simplify this. If we are going to simplify it, let's go ahead and start by underlining things. So anytime there's a value or a coefficient in front of a variable, we're going to underline that. So we have 10x and we have 4x. It's important to note that in this problem, we have a minus 4x. We need to pay close attention to the sign that is out front of our value, whether that is a constant or whether it is a coefficient in front of a variable. So here we would have plus 3, we would have plus 2, and we have a minus 1. We have 3 values that are constants in this problem. All right, let's not forget about 16. That's a constant as well, and we can also simplify and combine some like terms there. So let's go ahead and combine the things that we have together. We're going to start with just the ones that have a single underline. These are the only things that can be combined. We can't subtract or add 3 to 10x. Okay, it's the only things that have this in common, this variable in common. So if I have 10x and I subtract 4x, okay, you're logically thinking, okay, 10 minus 4, and that's exactly right. That's what we would do. So we would have 6x. Then we would look at our constants. So we have on our left side, we're going to go ahead and do that first. We don't want to cross our equal sign until we simplify each side of our equation. So if we're only looking at the left side, we have a plus 3. If we add 2 to that, we would have 5. So we have 3 plus 2. That's 5. And then we have a minus 1. Minus 1 would be 4. So we would have plus 4. The only time we would have a subtraction sign here after we did or combine like terms would be if this was a negative number. And we're going to equal to 16. We still have our single underline underneath our 6. This is the only value that has a coefficient now because we combined 10x minus 4x, and we have these two constants still. We can subtract 4 from both sides. That's opposite operations. So we would subtract 4 from both sides, and we would get 6x is equal to 12. And if you want to go ahead and try to solve this equation, you can. I'm going to put in the next scene the answer to this. So if you pause this, awesome. Make sure you got your answer handy. All right, let's go ahead. We have 6x is equal to 12. Remember, this is our simplified equation after we started with 10x plus 3 minus 4x plus 2 minus 1 is equal to 16. As you can see, this is way simpler after we simplified it. Okay, and that's the importance of simplifying equations. I should say it's simplified. Put a different ending on that. So 6x equals 12. We're going to do opposite operations here. We could think of what number can I multiply times 6 to equal 12, and that would be what x is equal to. But let's just do it mathematically. So 6 times x, so we're going to do 6 times x, and we're going to divide by 6. And we're going to have 12 divided by 6. Remember, if you do something to one side of our equation or the left side, we have to do the same thing to the right. So 6x divided by 6, well, any number divided by itself is going to be 1. So this would be just x on the left side is equal to 12 divided by 6. Well, that's 2. So x is equal to 2. We can go ahead then and check our answer. And if we were to do that, we would plug it into this equation here. We can plug it into our simplified version, and then let's go ahead and actually plug it into our real equation up here, our beginning equation too. So 6 times 2 is equal to 12. Well, yeah, 12 is equal to 12. Let's go ahead and plug it into our original equation. So it would be 10 times 2 plus 3 minus 4 times 2 plus 2 minus 1 is equal to 16. Almost ran out of space. So here we go. We have to do multiplication first. Remember PEMDAS. Please excuse my dear Aunt Sally. So parentheses, and nope, we don't really have any. I understand that we do have parentheses, but that's just showing that we're multiplying 10 times 2. So multiplication and division would come first here. So we have multiplication. 10 times 2, which is 20, plus 3, minus 4 times 2, plus 2, minus 1 is equal to 16. We're just going to do one step at a time. We're going to take this easy, follow the pizza slice method. So we can't do addition yet. We have to still have some multiplication in here. We have 4 times 2. So 20 plus 3 minus 4 times 2, which is 8, plus 2 minus 1 equal 16. And then we're going to do addition and subtraction, just left to right. 20 plus 3 is 23. Oops, I made a mistake there. Happy accident. Minus 8 plus 2 minus 1 equal to 16. 23 minus 8, that's 15, plus 2 minus 1. 15 plus 2 is 17, minus 1 is equal to 16. 17 minus 1 is 16. Is 16 equal to 16? Yes, it absolutely is. So we know that our value of x is equal to 2, or our solution here, all right, our solution set would be the number 2. It makes our equation true. So here would be the notes that I would want for this lesson. I have the definitions of both coefficient and a constant up top. I have a visual example of that to the right. The 2x is my coefficient. Well, the 2 is exactly my coefficient, and my constant is that fixed number of 3. Some tips to have when we were solving some of these equations, if you were having trouble with doing that, we need to make sure that we're simplifying each side of our equation before we cross that equal sign. And what that means is we need to simplify each expression, because if you remember, an equation is made up of 2 expressions with an equal sign in the middle. And we need to come up with a coding system to identify constants and variables. In this video, I used a single underline underneath my numbers that have a coefficient by a variable, and my constants had a double underline underneath of them. You can use that or come up with your own. Maybe you just use a certain color of crayon or colored pencil. And the last thing to remember is that if you do something on one side of an equation, either that's the left or the right, you have to do the same thing to the other side to make sure that you are keeping balance. That's it. I hope that you enjoyed this lesson, and there's more to come. Have a good one.